Hi, today I'm going to take you through the whole National 5 chapter for angles and circles. Okay, so you should be able to, at the end of this, and I'm sure you already can, but you could identify a chord, tangent and angle in a semicircle and use them to calculate the missing angles, and then use Pythagoras' theorem to solve a perpendicular bisector question. Okay, so let's have a look at some angle facts that you will already know. Okay, so angles around a point 360 degrees. We only use exact angles, okay, so we're not talking acute angles, obtuse angles, etc. It has to be exact. So then straight lines add up to 180 degrees. Vertical opposite angles are exactly the same, okay, so they'd be in a cross. So they two would be exactly the same. Okay, alternate angles, so your Z-shaped angles where they two would be exactly the same, that's because of parallel lines. And then your F shape where these two here would be exactly the same again because of the parallel lines. Angles in a quadrilateral add up to 360 degrees. Triangles 180 degrees. Equilateral triangle is obviously it's a special type of triangle because all three sides are the same, so every angle is 60 degrees. An isosceles triangle, two sides are the same. Okay, so 180, add to 180 with two angles being the same. Right, so going into parts of the circle, you've got obviously the centre point, then your circumference, which can be called your perimeter of your circle, your radius, which is half your diameter, goes from the centre point out to the edge of the circle, the diameter, two radiuses or two radii, which goes all the way through from one side of the circle to the other side of the circle, going through the centre point. Then you've got your chord, which touches the side of the circle and to the other side of the circle. It does not go through the centre point, okay, which makes it different from your diameter, obviously. And then your tangent, which touches it and only just touches it at one place, and it can create a right angle in there if you drew a radius to meet it. Okay, so let me give you the definitions again because they're handy to have. So a diameter, you can find your radius if you've got your diameter by dividing it by 2. Okay, you could find your diameter from, you could find your diameter from your radius by multiplying it by 2, okay, and I've given you the opposites there as well. The circumference, C equals pi d, would be the formula to find the circumference. A chord, so it touches both sides but doesn't go through the centre point, makes it different from a diameter. Okay, and we'll come on to the properties that creates in a minute or two. And then the tangent that touches the circumference but doesn't go through it, okay, it just touches it once. So, 3 important properties. Angles in a semicircle. These ones are going to create a 90-degree angle in a triangle. Okay. The angle created by the tangent and the radius will be 90 degrees as well. And then the angle created by the chord and the radius will create an isosceles triangle. And we're going to use these to find some missing angles. Okay, so let's take a look at the angle in a semicircle. So angles in a semicircle are created by two chords that are touching the edge of the diameter, and as you can see, it creates a lovely right angle triangle in there, with this being your diameter. Hence the reason why it's called angles in a semicircle. Okay, so as we know, this one here is 90 degrees. So to find the missing one, we're going to add up the 90 and the 47 to give you 137 degrees, and then angles in a triangle is 180 degrees. Take 137 off of that, so you're getting 43 degrees for x, so x is equal to 43 degrees. Okay, as we said, it's a right angle. Then, taking this one into consideration, there's my right angle at the top. Okay, again, here's my chord, diameter. Okay, now this is a vertically opposite angle over here. So that gives us this 45 degree in there, and that's what we need. Okay, because they two have to be exactly the same. So then we'll add the 90 plus the 45 to give 135 degrees. And then angles in a triangle add up to 180 degrees. So we'll do 180 minus the 35 to give me 45 degrees as that missing angle. Okay. Right, so tangent to a circle. It's perpendicular to the radius at the point of contact. Okay, so it creates a lovely right angle to triangle or right angle in there to help us. Right, so as you can see, here's my tangent at the bottom, AC. So what I've got is I've got a right angle down there. Okay, so that means I can find this angle here by saying I've got 58 adds up to 90, so I must have 32 degrees in there. Okay, now as you can see, I've also got my semicircle. There's my right angle there. There's my chord again. There's my chord, and I've got my diameter. There's my diameter there. Okay, so I know I've got 32 degrees. Add that onto my 90. So I'm getting 122, and then 180 minus that 122 will give me 58 degrees, which I'm sure you already could give me. Okay, then this one here is also an angle in a semicircle, so there's my 90. So this one down the bottom has to be 60 using the same logic. Okay, so a triangle is formed by a chord, and you've put two radii or radius at the end of it. Okay, so here's your chord at the bottom. Then you've got your radius here. Now these have to obviously be the same size. There's your radius there as well. Okay, so it creates, because they have to be the same size, it creates an isosceles triangle. Right, so I'm sure you can see the chord here, which creates a right angle an isosceles triangle, because they two have to be exactly the same. Okay, now it's giving you this. I've also got a tangent at the bottom here, so there's my 90 degrees. It's telling me that that part is 20, so that must mean that this angle in here is 70. Because it creates an isosceles triangle, this one's 70. Okay, add the two together, you get 140, and take it off of 180, I'll give you 40 at the top. Okay, now what you've got here, what I want to find is DCB, sorry. I'm looking for this angle. Okay, so taking all of that into consideration, this is the one here that I needed. Okay, now I needed that. Let me take out everything else. I will put it back in a second. But what I'm looking for is DCB. Right, so I'm looking for this angle down the bottom. Okay, but I'm sure you can see the big triangle, which is why I'm going to use that 40. Okay, because I've got 40 here. I've got 90 here, okay, which will give me 130, which means that this angle in here, the one that I'm looking for, is 50 degrees. Okay, bearing in mind we had 70 in here and 70 in here because of that chord at the bottom. Okay, so quick recap. Angle in a semicircle will give you a right angle, so you're 90 degrees. Your tangent will create a right angle as well, and your chord will create an isosceles triangle. Okay, so let's take a look at an exam question. Now, I want the angle CAB, so the first thing I'm going to do is I'm going to identify it. There, it's down there. Okay, so that's the angle that I'm looking for. What else can I see and find in here? Well, I've got a tangent. We've had that 58 before, so that's 32. Yeah, so then I've got a chord up here, 32 degrees as well. Okay, and I may as well keep going and find the one at the centre. So I've got 64. Angles in a triangle add up together to give me 180. If I've got 64, then I'm looking at 116 in here. Okay, now this is a straight line. As you know, they add up to 180 degrees, so that'll give me 64 in there. Now I need that to find the angle at the bottom. Okay, and then here's a tangent again. This is the other side of the tangent we had before. So we've got 90 plus that 64, which will give me 154 degrees. Okay, take that off of 180 degrees for your triangle, and you'll get 26 degrees down here. Okay. Right, symmetry and circles. So a triangle formed by a chord and two radius is an isosceles triangle, but if you put the line of symmetry down the middle, then you create what's called a perpendicular bisector, because this splits it at 90 degrees, perpendicular, makes it 90 degrees, and it splits it perfectly in two. So that side and that side, it creates two congruent triangles, and congruent just means that they're exactly the same. Okay, and there it's there. Okay. Now, what we've got, and a key to these questions, because we're moving into Pythagoras here, okay, is to identify the radius and how many like you could write in infinity radii if you wanted in here, but the key ones is to make sure that you've got the one from the centre point to the end, then down both sides of your isosceles triangle, and then one to the base as well. Right, so let's take a look at this one. Now, first thing I'm going to do is I'm going to draw in my right angle triangle. Now, as you can see, what I've just drawn in is I've just drawn my radius. Okay, and my radius is x, as you can see from this radius here. Okay, now I've got 15 centimetres there. This is a perpendicular bisector, so it splits it in two, so that bottom part is 20. Right, so let me draw out the right angle triangle that I've just found. So I've got 20 centimetres at the bottom, 15 centimetres at the side, and my radius is what I want to find. So I'm going to use Pythagoras' theorem. So c squared is equal to a squared plus b squared. Substitute in your values. X squared is equal to 20 squared plus 15 squared. Square them out, so 20 squared is 400. 15 squared, 225. Add the two of them together and take the square root. Okay, which means my radius is 25 centimetres. Okay, so let's have a look at a different one. Okay, so this time they've given me a radius here, okay, but they've also given me the height from that x up to the top. Okay, so what I know is I know that that is 6 centimetres. So this part here must be 2, and there's my perpendicular bisector. Okay, apologies that x is badly placed. It should be over here. Okay, so let me draw out that triangle so I'm a bit clearer. Again, we're going to use Pythagoras, but this time, as you can see, we've got our hypotenuse, so we're going to find the shorter side. There's my hypotenuse there, and I'm going to use the formula a squared is equal to c squared minus b squared. Okay, so I've got x squared is equal to 6 squared minus 2 squared, so 36 minus 4. So square root of 32. Okay. And you should get, I want it to one decimal place, so x is equal to 5.7. Okay. Now, if they wanted the whole length down here, apologies, like I said, that x is badly placed. If they wanted the whole length, you would multiply that by 2. Okay. So, we've taken you through all the angle properties in here, so your chord, your tangent, your angle in a semicircle. We've given you the angle properties that you needed at the beginning to be able to access these questions. We took you through an exam question for circle geometry, and then we led you into the Pythagoras' theorem for perpendicular bisectors. Both of these questions are very, very common at National 5 Maths. Okay, if you've got any questions, please contact us.